Hello guys, welcome to my YouTube channel. Yes, this YouTube channel. And if you're on this video, congratulations, you have made it. You've either graduated from O levels ZIMSEC or Cambridge IGSE. And it's a great step, a great leap from O level physics to A level physics. And that is why this channel exists, so that it can be able to help different students from different bodies. But in this video series, I'm going to be helping Cambridge students adjust to the Cambridge curriculum so that they can be able to understand how physics works and how physics can be made much easier. I'm going to be using relevant Cambridge specific examples and going to be solving specific Cambridge questions from Cambridge question papers so that people can be able to understand how these questions actually work. And one of the things that makes this special is that I'm not going to assume that you know a lot of things. For example, saying power is equals to voltage times current. I'm going to explain why that relationship is true and why that relationship is valid, so that you can be able to really understand what physics actually is. One of the things that I love about physics is that it's mainly much more about grasping different concepts and being able to understand these concepts in depth. So please, whenever you're studying physics, don't study physics just to cram and pass a certain exam. Really study physics to understand how these concepts actually work. And you find physics quite fascinating. Some of these concepts are really engaging, and they can be able to uplift your life, and they can be able to really make you see the world in a different perspective. So in this channel and on this video series, I'm going to be explaining A-level physics so that you can be able to understand. I'm going to be starting in this video on physical quantities and units, and I'm going to moving on to other different topics so that they can become much accessible and they can become really easy to understand. I hope that you like my video and you press the subscription button, so that you can be able to see much more of my content and be able to access it wherever you are around the world. Thank you. So in this video, I'm going to start off with the first topic for AS level physics, which is physical quantities and units. So before we start off, we'd like to first understand what is physics and how does it work. So physics basically relies on measurement of physical quantities. And it is of utmost importance that you are able to understand what exactly is a physical quantity, because it is something that you're going to be using. It is something that you're going to be rather measuring as you go on with your AS journey. So first of all, we'd like to get down with some definitions so that you can really be able to understand where we're going. Okay, so basically, a physical quantity is basically a measurable, it's a measurable aspect of matter. Okay, or in simpler terms, it is basically anything that can be measured. So if you ask yourself, can this thing be measured? You already have an answer, and it's going to be a physical quantity because in its respect, it can be measured. So basically, a physical quantity is made up of two things. So basically, they consist of, so whatever we call a physical quantity, it consists of, number one, it's what we call a numerical, magnitude. Okay, that's the first thing that it consists of. And number two is going to consist of what we call a unit. So what do I mean by this? A numerical magnitude really means anything. It can be a number. For example, just like saying 20, 30, 40, all of those are numbers, right? Those are what we call numerical magnitudes, right? On the basis that there's actually things that can be numeralized, right? Can be made up of a specific number. On the basis that these are things that are made up of a specific number, right? And the unit, you have to tell me what it is. Is it a kilogram? Is it meters? What exactly is it? So think of the unit and the magnitude as something that is really tied together. The unit cannot exist without the magnitude, and the magnitude cannot exist without the unit. Those two make up the physical quantity. And it is the numerical magnitude that goes first, then the unit that follows second. I always give this example of my name. My name is Keith Tangwa. So it's made up of two groups. One of it is my name, which is Keith. Then the other one is the surname, which is Tama. So wherever you go across the world, my name is always going to consist of those two parts. So the first one is the thing that follows first, right? It's always Keith, which is the first name that always shows up. And my surname is therefore the second. So my name can be different, right? I have multiple names. It can be Keith, it can be Anesu, it can be Rao. There are a lot of names that can go, but the Tangwa thing will always be constant. My surname is always going to be there. The names might change, right? My other siblings might have different names, but the surname will always remain the same. So they will always work together. The name first, then the surname follows. In a similar way, the name can represent the magnitude. The magnitude always goes first, which is like 20, 30, and the magnitude can change. It can be 20, 30, 40. But what defines a certain family or a certain group of physical quantities is their units. It's what makes them special. Saying 20 really doesn't mean anything, but saying 20 kilograms, you're like, okay, because you have said kilograms, you're hinting towards mass, right? So the unit is a special thing, like my surname. It's what makes my family unique and other families unique also because of their surnames. The names can change, but the surname must always remain intact. So in a similar way, a physical quantity must consist of a numerical magnitude, and it must also consist of a unit, and those two things must be tied together. So the syllabus requires us then to make reasonable estimates of physical quantities. But before we go there, we just need to get this idea to stick in. What exactly are physical quantities? So before we go there, we'd like to start off with base quantities. And once we have understood what base quantities are, then we can go back to that objective surrounding making reasonable estimates. So we have talked about physical quantities basically. So physical quantities are made up of two groups. They're made up of, number one, they're made up of the base quantities, and they're also made up of the derived quantities. So the base quantities are also known, okay? So we have base quantities, and they're also at times referred to as the fundamental, okay? The fundamental quantities, right? They're really those things which are really, really fundamental, and they're the things that really make up the whole universe. They really can't be expressed in any simpler form. So I like to define these as sort of an independent quantity, okay? So they're basically an independent quantity, right? An independent quantity in any simpler form. So basically, base quantities are independent quantities that cannot be expressed in any simpler form. They're okay the way they are. They cannot be broken down into anything simpler, and they all exist as independent quantities. So what are some of the examples of these quantities and how do they work? Right. The first quantity that I'm going to talk about is mass. Okay, so the first one is mass. And mass is measured in kgs, or as we call it, kilograms. So whenever we talk of mass, we have to talk of the kilogram, right? And mass is basically the amount of matter that is contained in a substance, like how much of something really exists. For example, we have a student named Rob, and Rob stands on a scale. So for you to measure mass, we use what you call a balance. It can be an electronic balance. It can be a triple beam balance. There are a lot of balance that are sort of used to measure mass, right? Some of these balances have been discussed in have been discussed in IGSE or in O-level physics. But here we just, sort of just mention that mass can be measured using a balance. So let's assume Rob weighs what we call 60 kilograms. What does it mean? It means that the amount of matter that is contained in Rob, the amount of Rob that actually exists is 60 kilograms. It weighs 60 kilograms. So when Rob stands on a scale, the scale reads 60 because that is how much Rob weighs, right? So mass is basically the amount of something that are there. It means that his body, his legs, his arms, his head, everything, all of that has an overall mass of 60 kilograms. That is exactly what mass means. The next one that we can talk about is time, right? Time is very important, and time is measured in seconds, right? So time measured in seconds is basically a physical quantity. Can you break down time, really? Can you say, I have 6 seconds, let's break it down to something else? You can't, because it's fundamental, it's basic. You can't break it down any further. For example, we use a clock, a stopwatch. Those are some of the things that we use to measure time. You can tell me that it's 2 o'clock. It's not going to be broken down any further. So time can be measured in seconds. And seconds is basically what we call the SI base unit. You might be wondering, why SI? What does SI mean? So SI is basically the International Systems of Units, which is like an internationally agreed convention. So that when people would be speaking, it was agreed at a conference which was held in very long ago, and they agree that whenever we talk of mass, we need to speak a universal language. Something has to be the fundamental quantity that exists, and it is the kilogram. So whenever they talk of mass, for example, it's going to be the kilogram, and across the whole world we might have other different quantities, but the one thing that we're going to agree on is going to be the kilogram. So those are the SI units, the units which have been agreed universally that we're going to be applying. So whenever we talk of base quantities, we have to talk of the SI base units that apply to those base quantities. So for time, it's going to be the second, right? They can also be minutes, years, hours, days, months. There are a lot of things that can also be falling under time. The next one that we're going to talk about is thermodynamic temperature. Okay, so the other thing that we have on the list is thermodynamic temperature. And what is temperature measured in? Temperature is measured in kelvins. And kelvins is named after Lord Kelvin. We actually discovered this whole scale, the Kelvin scale, which is a substitute for the degrees Celsius scale. They sort of work hand in hand. And you're going to learn much more when you're doing now thermodynamics in much greater detail. But basically, thermodynamic temperature is measured in kelvins, and temperature is basically measured using a thermometer, right? There are various kinds of thermometers, like a liquid in-glass thermometer, a thermocouple. There are a lot of thermometers that are really used in the measurement of this physical quantity. What else we've got? On the list, we have electric current. What else do we have? We have electric current, and current is measured basically in amperes, right? So basically, current is measured in amperes and is measured using what you call an ammeter. As you can see on the screen, an ammeter is used for the measurement of current, and it's very important for you to understand it, because when you do the topic of electricity, we're going to really focus in depth on what electric current actually is. The other physical quantity that we have is going to be length. Okay, that's the other physical quantity, which is going to be length, right? And length is basically measured in meters. So what is length? Length is basically the distance between two specified points, how long something is. For example, I can give you a table and ask you, measure how long the width of the table is, or from point A of the table to point B of the table. So you're going to use maybe a meter rule so that you can be able to measure that length. So length is basically how long, therefore, something is. What really can we use to measure length? It can be a tape measure. As you can see on the screen, it can be a meter rule, and there are various kinds of meter rule: 50 centimeter rule, 30 centimeter rule, a meter rule. So there are various kinds of meter rule. We also use a vernier calipers, and we also use a micrometer screw gauge. So those are some of the things that we use to measure length, and it's very important that you're able to understand what length is and the different even units that exist for length, like the centimeter, the millimeter, all those different units that exist for us to be able to measure length. So basically these 5 quantities, okay, so basically from here up to here, these are basically the quantities that are required for you to know in AS, right? But the 2 quantities, I'm just going to talk about them, but they're really required for you to know when you're now in A2, which is the level that follows after AS. So these ones are basically the amount of substance, right? Which is the amount, right? The amount of substance. And this is measured in mole, but you're going to discuss more of this when you're now in A2, and we're going to focus on that again when we reach that level. Then the other one that we have is going to be luminous, okay? Luminous intensity. Again, we're going to discuss this in detail when we are now in A2, which is going to be measured using the candela. So these 2 are required for you to know in A2. Now that we have a basic understanding of what are base quantities, and quantities, remember, they're physical quantities. Why? They have magnitude and they also have a unit. Those are the 2 things that must be ringing in your mind whenever you hear the word physical quantities.